wrote this song, by the way. It's got an 80s vibe. It's supposed to be copyright friendly. I hope that it is. Okay, so let's go ahead and see what we're starting with. This is a shameless corruption of the example from Ursina, and let me just show you what it looks like so far. If I can get it. Let's see. I'm in the wrong directory, I guess. Maybe not. Let's see. Copy. Path. Yeah, okay. We're in samples. Oh, is it? Every time. La 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 la. Hello. Every time, dude. Hold on. La 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 la. Can you hear it now? La 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 la. Oh yeah, you can hear it. Cool. Well, anyway. CD samples. You can hear it, right? Let's see. Got a little error here, an unexpected indent on line 98. Let's go ahead and correct that. And yeah, I think I don't want this right now. Awesome. Glad you can hear it. Low volume. Hold on. That should fix it at least a little bit. Here, that should do it. How's that? Get the music back going. Probably can't hear that now. Yeah. All right. So 9-ball triangle. Let me get that good now. Thank you. I appreciate that, man. All right. So this is the Ursina game engine, and right now I've made it to where I can launch these balls. And there should be a slight bit of friction so that they will stop. Yeah, they do stop. I made it pretty low. But what we're gonna do is we're gonna try to make sure that they are able to collide with one another, which is something I was kind of having trouble. So if I get this at the right angle, let's see. Yeah, you can see that they do collide a little bit, and that is the result of my collision algorithm. That is here. Elastic collision. And the funny thing about working with physical objects is that you cannot really, it becomes limited on the processor pretty quick because it's a lot of math. So you have to really be careful. Like if I sit here and put too many balls in here and they're all crashing around, it will, I don't know, it'll perform badly. All right, so I got balls, they collide. Let's see if we can arrange the balls in a triangle. I think what I want to do is make a pool game, billiards, and it will be a good way to make sure that my balls are working properly. So the first thing that we want to do is we want to define that the arena area is, well, first of all, let me try to see if I can make it grass. See if that works. Yeah, that looks slightly more like a pool table, but not really. At least we can just say that we're like outside or something. Okay, so I want to arrange this in a more of a rectangle rather than a square. So I think that we do 32, 16, 0 here. No, that's the texture scale. That's wrong. So the scale is a plane. Let's see. I'm not sure if how we can make this into a rectangle. Maybe 32, 16. Let's try that. Oh god. Alright. Well, that did something. Alright. See if we can fix that. Okay, now I'm standing on this tiny thing here. And how many of these do I have? 1, 2. This looks like 32. So that second argument is not going to be the width at all. So, I mean, what if I change that to 64? What kind of effect? I'm literally figuring out the arguments. Nothing. What if I add another one? Terminal. All right. There we go. All right, there we go. Bigger arena. Possibly 32 by 32. Let's see, 16. Yeah, okay. So now we're at a 32 by 16 rectangle, I believe. Is that, yeah, 32 by 16 rectangle. These blocks, though, are not rectangular like I would like them. I think we'll probably have to draw it. I mean, I'm not worried about that, really. I'm not worried about rectangular blocks if I am making a pool game. So, anyway. This music back on. Alright. So, with that. And so at the end of this, I want to arrange these balls in a triangle like a pool game. And then right now, I can just launch this. So I'll just launch it into it and try to make it to where they, you know, it's going to be like pool game. So that's what I was trying to do here with arrange 9-ball triangle. We'll go ahead and get back into that. And we are just simply, yeah, that was the problem there. So if I take out that little typo, what kind of thing can I get here? Alright, it kind of looks like a triangle, and it's kind of moving. I guess my first question is, yeah, it doesn't quite interact the way that I would want it to. And that's weird because it seemed like it was a second ago. It looks like it transfers from one ball to another. But there's no... Seems like there should be more. Alright, let's see if we can add a little bit of the, a little bit more force on the ball coming out. So that really is just velocity for us. Let's see, so when we get the input, we're adding a position that is 0.5 forward plus player.forward. And that's interesting. It has this, I guess it has the same momentum as me. So what happens if I change this to 5? My ball's going faster? Not really. They're starting higher. So it must be, let's see, they're rolling. Let's see, let's go into my ball class. Aha, so I'm starting it with a velocity of 2. So, I mean, let's change it to naturally a velocity of 10. And I think that's modeled incorrectly, actually. Nope. Not working. Alright. So where else is the velocity set? So 2, 0, 0, 10, 10. Just curious what these numbers do. Oh, Jesus. Oh, fell off again. So my balls are launching pretty quickly. And it seems like these balls that I am launching from here are not, maybe not a ball class. They are a ball class. And the position is the only thing that's different. which is weird. So for the ball class, we don't have an update function, so that's all Ursina. So I'm guessing that Ursina gives it a velocity by default. Let's see. If I just comment this out, do we have some stationary balls? Yeah, they will never move, or I guess they will move once I do transfer momentum. And my balls that I'm launching are also still moving. Alright, so we have to figure out why they're still moving. Okay, so we have another class here called physics entity, and these physics entities are started with a velocity of 1. So that is currently being called and then superseded by this. Okay. I don't want all of my physics entities to start with a specific velocity. I don't even want the balls to start with a specific velocity, I don't think. Unless I pass it in. I'm not really worried about it. I just want to make it faster, just so I can prove that I'm working with the correct thing here. So, I don't know, 5 in that. Alright. So the parameters for velocity, I believe, are X, Y, and Z. They do look like they're going a little bit faster. Alright, let's change it to 10 then. And these should all be derived from the player's facing direction. So I'm not worried about it right now. It's just basically some future thinking stuff. Doesn't look like it's going much faster, I'll be honest. Those balls out there, let's see how they started. Hold on. Yeah, they start with that constant velocity, but mine doesn't, it looks like. Or, the balls that I'm spitting out, they look like they're the same. If I change this to 100, let's see. Yeah, they're still the same speed, velocity. So, somewhere else, something is going on with these guys. So we do have an update function. And we have fall and advance. Okay. So this is entirely controlled outside of okay, so now it's kind of becoming clear. The ball that I have here is not really appended to my physics entities, so it's not checked for collision in the game loop. And so therefore I have to change this. So, also these balls have this velocity. Interesting. Okay. I have too much going on here, I think. So, entity, advancing the entity. Trying to figure out if that's something that should go on the physics entity or not, but I think that it shouldn't. So, where we have ball, we have hit floor, which is also something that should not go specifically on the ball. Hit floor should be something that is on the physics entity, like that. And calling a new ball appended to, okay, so it is appended to physics entities. The only thing that I was seeing is that the velocity is set here, so everything else is fine. Let's make it go faster. It's immediately set. And that's a funny thing with Python. You can just set. The ball has no attributes called velocity. I must have gotten rid of it. So in our ball class, or actually just the physics entities class, since it will inherit velocity, we can assign it to a, let's see, how many times do we have velocity? Quite a bit. Alright, so I'm not going to do the underscore thing. Freak it. Yeah, I will. Alright, so velocity gets replaced with velocity like so. And, yeah. And then I'll have double velocity one time here. Just delete that. Alright. right, and that's a convention for naming private properties, starting them with an underscore. And there's another one for arguments that get assigned to private properties. Postfixing them with an underscore. I don't really care. This is not going to be a huge game. All right, so here's my balls. I'm stuck in the middle of them. And they're almost a triangle too. So let's launch that motherfucker. See that? Now we got some force there. There we go. It actually does a pretty good job of transferring the momentum too. Ooh, look at that. That was weird. I'll figure out what's going on with the weirdness. This is fun. There's no negative momentum from the ball. There's no rollback, and that's a problem. That should be happening according to the formula. So if we're gonna make a pool game, that's gonna have to happen. I'm like launching them into the ground there. All right, well, this can be fun by itself if the pool game thing doesn't work out, but we'll figure it out. All right, so the problem that I'm facing right now is that first of all, I guess way too fast. Yeah, cut that down to 25. I didn't want it to be fast enough to hit the balls and transfer the momentum. Then the other problem that I'm having is that the velocity of entity 1 is not really, it's not being transferred on. Oh, do we have masses of 0? No, we have masses of 1. Well, we have a mass of 1. I don't know, change it to mass of 2. Let's see what kind of effect that has on the physics. What the heck? Okay, back in business. And so change it to mass of 2 again. And I know that wasn't what messed it up. All right, mass of 2. The middle of my balls again. Still no bounce back. The momentum is like completely transferred. Like it seems like the momentum of 0 is transferred onto the ball, but really it needs to be the momentum. It needs to be the momentum. Here, I'll just do it. It's easier for me to just do V. And I guess there's no reason to... Alright, hold on. Minus V2. No, it would be V2 minus V1 in a negative direction. So it will... And then, I don't know, it has to have a diminishing factor. I know that it does. It can't just be negative... Like, it can't go from 1 to negative 1. It has to go from negative 1 to, like, half. Or something like that. But we'll just say point. What is U1? Entity 1 velocity. Hey, you know what? That looks pretty good to me. I don't know why I would do that, but it looks good. All right, so yeah, okay, so all right, so U1 minus U2. So the differential velocity cut in half. That's pretty much what I want. V1 and V2 in this case are the adjusted momentums. And I think that that's only accounting for mass. Yeah, I do want to account for mass at that point. Right? Because we have mass M1 and then U, which is the velocity. And mass times velocity is force, I believe. So this is like the momentum force, I guess. I don't know. Not a physicist. But, so I think instead of doing U1 minus U2, it would be V1 minus V2 here. And we can try both. And it's cutting it in half, which is good. Which means like every time the ball hits another ball, it will lose half of its momentum in the reverse. All right. Let's see. Yeah, that's not what we wanted. That is not what we wanted. Oh wait, something happened. I saw a rebound ball. I know I did. Yeah, that's not what we want. Okay. So, it may be the opposite. That's what I kind of mentioned about, anyway, well, I'll just show you. So V1 is velocity 1, and then, yeah, I'll just leave that the way that it is. I want to see that the velocity is transferring to the secondary object at least. Yeah, I still don't see that, so I'll put it back. It was just V1, V2. And there may be something else to adjust here on V1. Probably should figure out which V is V. I don't think they have any actual ordering other than like what was the last object that was applied to the physics array. So let's see. Yeah. All right, so motion's transferring. I would like to see some pushback. And I think that the problem that we're experiencing here is the fact that the adjacent objects also have mass. And it doesn't seem to be factoring in. So, yeah, that's bad. But that's the next thing to deal with. The first thing to deal with is to figure out, like, where... Okay, so if I change V2 to just 0... my effect of that should be that the ball that I'm hitting, what I expect is that the ball that I'm hitting, what the hell happened? So is this like a, this is like a vector? So if I multiply it by 0, then that should happen. Or that should be what I want. Not just the 0, it has to be an actual... Yeah, so what I thought is happening, we're not transferring momentum at all. We're setting the velocity of the secondary object to 0. And then just to, like, understand that this is the target, I'll set this one to whatever it is, like v1 dot y, v1 dot z, and then the x I'm just going to set to an arbitrary -0.5 so that I can see what effect it's having on my balls. All right. What the hell? Can concatenate a tuple. Can't concatenate a tuple. Vec3 to tuple. It says it's there. Okay. All right. Well, then I'll just multiply by -1. That might actually be the entire thing. Hold on. Nope. Hey, we got some pushback. That's great. I think that's the entire what's missing from the formula, to be honest. It's just a negative. I mean, obviously that's wrong. This is not the way to deal with a bounce back. But what if we multiplied instead of, yeah, exactly, by 0.9 or -0.9? It doesn't seem to be negated properly. So now it does bounce back occasionally. So I don't think we're properly accounting for momentum and force. I think we're mostly just going by velocity and then just guessing, which is okay. Kind of. I'm just gonna play with this, see if it's any better. So we'll change this reflection factor, by the way. And yeah, no impact. In fact, did I lose out on... It it seems like I lost out on transferring the momentum by making it whatever. Yeah, okay, I'm still transferring. It's just stopping. It looks like here, let me reduce the number of balls here just to 2. And we can see like a better idea of how a ball is supposed to be. Okay, where the hell am I? Come on now. Alright, there we go. Alright, how many balls do I have now? Yeah, just 2. And right there, it's colliding with the other ball. It's going past the other ball. And right there, it transferred all the motion. It went from here to here to here to here, kind of. Looks like the collider might be off is the only thing. Like, all right, let's transfer, let's make it 4 balls now. And we'll study the collider. Observe the collider. So 4 balls. What the hell's my range loop? Where the hell is that? Deleted it accidentally? It's weird. Alright. Did it again. Gotta be careful. Alright. So now we have 4 balls. And it looks like the appearance is that 2 of them are touching. And one of them is not touching. And I think that that's the illusion of the hitbox. The collider box. So I hit that one, and it's now inside of this ball, basically, which is wrong. And now I hit this one, and it's still inside of that. It looks like it's being stopped by the same ball. And let's see. Now repeat the experiment for the ball that looks like it's not touching. And it advances not as much into that ball. Let's see if I hit it from this side. Yeah, it's not able to go inside of that ball. I think that the collider box is too small, is what I think. I wonder if we can show the collider, but I don't know much about this engine. Alright, I'll tell you what. Let's go make this faster again. Alright. So that ball went off the map. That ball, you know what would help is if I made them all different colors. So let me just do that. I hope, here, hold on. Do I have color anywhere here? Color red? Yeah, okay, so I think I just get rid of that in Quargs or whatever. Does that still run? Does it have a default param? Oops, hold on. That's all I need for now. Color red. Red is my favorite color, by the way. Alright. Yeah. So now they're white. So we haven't specified that they're red. And now we have a cool snowball game. Alright, sorry. What was I doing? Oh yeah, the colors. So we want some random colors that we can just give it. Fine. Alright, I guess that's good enough. Yeah, that works. It's gonna give me sequential. numbers, but the problem is with that is I need to modulo it. Yeah, modulo it by len colors. That way it will only give me a number between 0 and the actual length of the colors. Right. Okay, so what is this? Color purple. Ursina color does not have a purple. Well, that's not too bad because it has all the other ones. Right? Alright, now we have a little bit of color here. So that we can tell what's going on a little better. So it launched a green ball. There it launched 2 balls. So it must be, it's inching them forward, moving the hitbox. I mean, that itself is pretty cool. It's like a DNA science project or something. All right, so if I could show the collider, I think I'd be able to get further. What's that, man? Alright, so let's see. Ursina, show collider. Let's see. I probably should have read this. Oh, so we need to use array cast, huh? Casts array from the origin in the direction with a length distance and returns info containing information about what it hit. This will only hit entities with a collider. Okay, so what is the example that they've given here? So we have self.direction. So this is, they're trying to walk forward. And hit info. What is origin? Self.world. Self.up 0.5. Slightly up from the ground. Okay, so we ignore self. So this is just casting a ray. Okay, so let's see. Boxcast is similar to raycast, but the ray has thickness, height, and weight. All right, so I guess that would be like if we had a lot of if we cared about the edges very much. Intersects. Check if an entity intersects with a collider, intersects with another collider. That could be useful for what we're doing. Mouse collision. The mouse does raycast automatically. Space. Mouse. So there's a mouse object. Okay, that's cool. So the specific problem that we're trying to solve is the balls that we're working with are not quite behaving correctly. They are transferring the momentum in a way, but kind of acting a little bit whack, if I'm honest. I think honestly there's a decay factor. Not only is there like the balls should not be allowed to go inside of one another. That's obvious, but I guess it's a matter of finding out why that's happening, and I think that's probably the next step. So let's go back to those few balls that we had, and that time it did not, but if they're pressed up against each other like this, it'll clip through the ball first of all, and then it'll end up inside of another ball, like some kind of DNA project from 6th grade. So I guess that's problem number 1, is the ball going inside of each other. So let me slow down the balls back to 10. No problem there. There's the problem. okay, so what happened? The ball tried to advance, and it was able to. I think that's really it. It advances before it actually checks the collision, and that's probably like a logic. Hey, can I ask you why you're doing this, if you don't mind? This is for fun. I don't believe that I'll be able to make a game, but, you know, I think studying physics in this game, or, you know, in game development is pretty cool. You can learn a lot from it. Thanks for the question. All right. So, back to playing with my balls. All right. It's just like almost there. So I think what's happening is it's advancing before, yeah, see, this is a no-no. This I think is the no-no. So let's see. Oh, hi. Hi. Hello. Hi, ZXC. It's nice to see you. Thank you for joining. I'm playing with these balls at the moment. And as you can see, they're rolling. They're transferring momentum. That looks pretty good. Until we get right here and these balls have merged together. And I'm suspecting that it's because my advance takes place before the... I mean, what if I just move it? Then that might actually work better. So it not only does it need to move, but it needs to, I think, return for this physical entity, which means I'll have to restructure my function a little bit. So, but for now, I'll just move the advance to there, and we'll see if that works better. All right, jump out of my balls real quick. The goal is that the balls are not supposed to merge into one another, and it's kind of working a little bit, I think. Oh no, well, that's a different problem, I think. I think I'm able to place them inside of one another. Yeah, but that's not really that's not what's going on with my, my collision detection. So, still a problem with it though, I think, because we have balls that are still advancing into one another. And so, let's see. When we are calling check collides, this is probably where it is. If entity 1 intersects with entity 2, that's the default Ursina thing. I guess that's really what I was talking about with breaking out of the function. So, all right, I think I can just save this to a variable, colliding equals checks collides. Everything will happen pretty much like that. The only difference is we're only advancing if not colliding. If not colliding. And then I think we'll have to, if we're colliding as well, there has to be a pushback possibly, and that might have to be a separate function for pushback. Transfer momentum should handle it, but I'm worried that if we're like not advancing here, we'll see. Let's see if the balls are stationary. Transfer momentum. What did we do? Oh, it's this Python. Let's see, 89. What else? Colliding. Oh, we don't need that there. What we need, so let's refactor this. If E is not equal to E2 and colliding. Yeah. Let's just try that. Where are we at now? And colliding. Oh, colon. unbound local called E2. Oh, okay. So this will have to be moved to an else if here, unfortunately, and I don't else. Yeah. So you want the balls not to get into each other when they're colliding. Yeah, that's exactly what I'm trying to do. The balls are going inside of each other, and I'm trying to make it to where they're not going to do that anymore. And I think moving the advance function call helped a little bit, and there's just still a little bit of work to be done with the collision. Okay, so now we're not even moving at all, and that's because we are never advancing. Oh, we have, okay. So advance, wrong function. All right, so, okay. Yeah, see, still going inside of each other. I'm gonna blame it on the freaking hitbox, which I think I can make bigger. Let's see. And now my balls are actually starting from way over there, not my origin, which is interesting. They're shooting out of the side of the thing. All right, let's try. So when I started, they appear to be coming from me. Now, okay, I think they're just going too fast. They're in the floor, and they're going too fast. So yeah, that's another thing to adjust. All right, so if we're using a box collider on a sphere, do we even have a collider? Hold on. So I think that's probably going to be it. Let's see if we can specify the collider as being a sphere. I don't know if they have a sphere collider. I hope they do. We may have to make one. I got multiple values for keyword argument collider. That ain't right. So there I'm. Okay, so here we got collider is box. That's the ground. And when I'm creating a sphere here, it has a collider of sphere, which is good. And then here it is, those also have a collider of sphere. They're supposed to. And I think that it's possible that the collider is not actually specified. If I am passing in the pointer of kwargs, KWARGS, I think that means that it is specified. And it's specified twice, and that's why, let's see, what are the other colliders that we have in Ursina? Collision. So yeah, mesh, sphere, and box. I mean, how am I gonna prove? Oh, okay, so this is the actual e.collider. So an entity, to make a sphere collider, you're passing in this, and then you can specify the center and the radius. Okay, let's try this. So quite crudely, let's go to the where we're calling the balls in. Actually, no, we'll have to do that in the ball class. So ball here. And what we'll do is we will specify that the collider is that, I guess. I did it here with the color. I'll do it again like this. So collider. And I'm not sure if here is supposed to be self, since I'm extending physics entity, and physics entity is also extending entity. So the center of 0, 0, 0 and a radius which I think should be 1. I think I'm specifying not 0.1. Jesus, hold on. Not 0.1. So for my ball, I think I'm specifying that it is a 1. Let's see. That's the position. I don't see anywhere where I'm actually specifying the dimensions of the ball. The dimension. I guess there's only one. Would be the diameter. Not there, that's for sure. And then, yeah, not there. Starting positions, but I don't think that's it. That's just an array of positions that I defined. All right, well, let's see about giving it some dimensions. Let me check. So I have a physics entity here, and it defines the model as cube by default, and that's not right. And that could be what I'm dealing with, actually, this entire thing. Let me get rid of that. And it does define, I'm not sure, I can't think hard enough to know if that's actually going to be affecting it. Let's just get rid of all of that. The only thing that I have here as far as a physics entity goes is the ball. So it's the only one I give a shit about. And so when I am not specifying the collider and I'm passing it in down here as a sphere, let's see if that fixes it in terms of making the collider act more like a sphere. No. In fact, I'd say that's quite worse. But the fact that it's worse is actually a good thing, because we know we're further away from the answer. Let's try to get closer to the answer. So we'll set this collider here, and we'll see if that makes a huge difference. And run it. Okay, what is this? Return null. Entity attach new node. Alright, so here where we're extending. Let's see. It can't be self there, I guess. Let's see. I know that we're doing super there. I'm wondering, I mean, the collider would have to be passed in. So let me go back to this documentation. So here we have entity, but since it's taking, oh, that sucks. Hold on. I guess, yeah, I'm pretty sure I can just do, those look like, what do you call them? Lists in Python. So I think I can just do I think I can just index that. Right, so if I have a collider already there, I guess first of all, the collider that gets passed in here is only a string. Like, it looks like this. So I'm probably doing this wrong. I'll probably have to do this after it's initialized. I have to apply the collider after it's initialized, but not string. It's what was it? Sphere. Sphere. So yeah, let's see what this does. All right. I think that is not even back to where it was, but it is again somewhere. So if I wanted to get it back to where it was, to where I did have a collider specified as a cube, and I'm looking at model too. I wonder what model comes into play. Actually, collider is specified as box. Okay, well, whatever. Let's see. So what I want to see is that less of objects getting caught in one another. What the fuck? I don't care about this whole line. I don't care. All right. Yeah, so it's still doing it. At this point, I don't know if it's, the only other thing that I did is I changed advance here. It's possible that that didn't even fix anything. So just look at it as the collider instead. I'm just going to specify this as a sphere, and I'll change the model also to sphere. I don't think that those things are being passed in. I can verify that. Hold on. Case sensitive on ball. Starting positions. Collider is sphere, but model is set to cube. So sphere, cube. Yeah. Let's just see what sphere does. Yeah. Not an issue with the collider, I'm guessing. We can try to make it a bigger radius on the collider, I think, after the class is initialized. Since we're only passing in a string, and we would have to add a box collider at custom positions and size. I guess I can just do this. Hold on. So I want to make the collider really big so that I can see like what it looks like if it has a big collider. Let's see, physics, entity, and yeah. So instead of collider here, we're gonna give it this initialization of box collider. Actually, sphere collider. Hold on. I need the sphere collider instead, which has a radius instead of a. Man, it's really looking like. I swear, it looks like the wrong collider. Because it's returning. Anyway, there's a default function that's in play here. Okay, yeah, this is copied over. I just need to get rid of that. All right. Come on. Self.e. Okay, sure. But I don't think it's selfie. I think it's just self. No. Oh, maybe it is self.e. I don't think I can do this here because there's no reference to a physical entity at this point. That would happen after this call, and it would turn this collider into something else. So let me remove this. Self.collider equals sphere collider. Self with radius 1. Quarks sphere super init model sphere radius 1. Okay. That's wrong. Let's fix that. Okay, so now you can clearly see that we have a much bigger collider. Colliding with just objects kind of randomly, to be honest. That might be the issue. We're not colliding with the objects in sequence. So if we are able to launch them in sequence, then they will collide in sequence, or they should for the most part. Right? Okay. So if we have a collides function, then we can change the color of the ball to reflect which ball we're colliding with. Let's see if we have something that we can override. I guess instead of that, we have this intersects being called here. So if they're intersecting, then we can just change the color, I think. And then we'll change the color of the rest of them to a different color. So here, I mean, I don't want to overthink this. Entity2.color is color red. So let's see if this is changing the balls that were. Okay, it does change my balls color. Interesting. All right, so they're all intersecting at first, which is interesting. Let me scale back the collider, the custom collider that I created for my ball class. Ball. I always lose it. Ball. I'm on caps. So here, that's not it. So I guess I applied it to the physics entity class, but that's not correct. I need to apply it down here. Yeah. And yeah, don't knock me on this bad code. I know it's bad. You don't have to tell me. All right, so when we hit these balls, they should be, yeah, colliding. And my radius is too great. I don't know what the actual radius is. I mean, if I set the object, the sphere's dimension to, you know, the actual diameter, I could control that. I can't see what it is by default. I assume it's 1. So yeah, balls are getting stuck in each other. No big deal. And then they're all turning red at first. So I think I want to save the color that we're passing in. Not there. So the color of the ball will be saved to this private variable like this. And when we are passing in the color, first thing we'll do is assign it to the private variable. Is not that, but this. And then this, we can let this go away and instead assign it to self.color. And let me just verify that. No, I'm not going to verify nothing. So it has its original color and the color without an underscore, which should give us the red. So we'll do if it intersects, then that, and then else we'll do entity2.color equals Jesus. Entity2.color equals entity2_color. So kind of giving it its original color back, I guess. All I see is red. All I see is red. So if I comment this red out, does it work? Are we intersecting with everything? Is that what it is? That might be it. It's if it's intersecting with everything, then that's kind of an issue. It's interesting. I thought that the intersect function was, is it touching something? But apparently it's not. So let's see. Raycast, boxcast, intersects, hit info is returned by what? Intersects? Intersects.hit? Interesting. Okay, so if you call .hit, then that is, I think that's where possibly what we're missing altogether. And yeah, I want that to be entity2, returning true, and let's see what we get there. Still turning red with everything. So I did do entity2.hit, and I don't know, turn them yellow. Now we have 3 yellow balls, which is interesting. And when I hit the one that's not yellow, it turned yellow. So it is working. It's just kind of difficult to see totally. Alright, so we do know. Alright, what other colors do we have? So I'll take red out of the running for these colors because somehow it's getting too many reds or something. You know, I don't care if they're intersecting with other balls at this point. So maybe just a separate little check for if it's touching the player. I don't know. So the player object is here. So I'll go, wait, no, not the player object, but the last ball. So the last ball that was thrown was physics entities. So last ball is equal to physics entities, I guess -1, yeah. And then if if last ball intersects with, no, wait, hold on. So here we'll do only turn it yellow if last ball equals entity 2, because I think that, I don't know, we'll figure that out. Shoot, what's going on? Return true. Oh, this, I'm missing this. I think I have to turn them both red. Let's see. Bro, since you are working with balls, you might know about this. I found an easy algorithm to calculate the intersection area between two circles. Do you know of any doing that for 3 circles and even better for n circles? Let's see. So the way I would do it is I would get like the total radius, which would be getting the average position of the 3 spheres. So like you have 3 spheres, they could be touching, they could be, far away. So I mean, if you have the spheres and you can detect, like, I don't know, the outermost point of each, like make a triangle. I don't know, I'm guessing, dude, by the way. And if your circle's radius is like the sum of all the radiuses is less than the triangle that they're arranged, that means that they're spaced far apart. So the sum of all the, like if you take the radiuses and probably like add them together, and they're further apart than the area of the triangle. But then if we find out they overlap, you can do that to check overlap. How to calculate the surface area of the intersection. Yeah, that's tough, dude. So no idea. Honestly, this library has a raycast. It has a raycast function. So I wasn't planning on doing any of that stuff myself, to be honest. I was going to use this stuff, and when you add another service area to the service, yeah, it is handy. I would definitely recommend looking at this Ursina library. Just take a break from whatever you're working on and just see how they do it, because you can even peek under the hood at some of this stuff. It's open source. All right, I gotta go. I gotta get my kids ready for work, ready for school while I get ready for work, and I'll be back in like, I don't know, 20 minutes, something like that. Yeah, you too. Thank you for joining in. I really appreciate it. Alright, and while I do that, I'm gonna have some balls flying around randomly or something. Let's see. Oh yeah, def. Move balls randomly. what the hell that is. Let's see. Update. Yeah, sure. So we'll comment out the update function. And then what? Maybe we have to cancel out gravity or something. All right. So where the hell is it? There we go. They're not moving. Oh, they're just stuck. Let's see. It didn't work. The generated function did not work. Why? Because is velocity with an underscore? Yes, it is. And it depends on what? Random uniform times 10? That should work. I mean, I don't see why that shouldn't work. Oh, God. I'm trying to make it to where there's something interesting on the screen. I could float them. Let's see. Float them up. I don't know. Let's see. Float ball. Yeah, well, that doesn't actually change anything, so. Floating direction. So let's see if I can. Let's see. So move the ball slightly. There. I'll give it more instructions. So floating top, floating limit is 1. So once it reaches the floating limit, then it should. So yeah, if y is greater than floating limit, but else if y is less than negative self dot floating limit, then the floating direction will be 1. And so self dot velocity equals self should be self dot velocity dot x 0. It's not 0. It's self dot. It's actually what, like 0.1 times self dot floating direction and then self dot velocity. Does that work? Let's see. Float ball has to be called in all my physics entities. So like right here. This is interesting. Fall is only being applied to the current physics entity. That's interesting. I knew that wasn't gonna freaking work. Can I make them constants or something? Oh, I have to make it vec 3, but this should be. First of all, does that work? Man, I gotta go. My kids are waiting for me. All right, so yes, I think that the only thing is times, actually instead of velocity right there, let's go 0.1 times self dot floating direction. All this just to make something interesting happen on screen. And it's still not working. Oh, they're doing something. They're like jiving. Yeah. It's way too fast. It's way too fast. Okay, so the floating limit. Get ready. Oh. Yeah, no, okay. Oh, it's okay. So it's not going to be good enough to just, it'll go from 0 to 0, I think. Let's see, it starts off as 1, so it sets the velocity to 0.1 times 1. I don't know, that seems right, actually. I don't think this is a proper upward translation. Let's see. That's probably what I'm dealing with. The balls look jumpy, but I don't think that's what I'm actually looking for. I am calling float ball oh, call it on E2? Haha. Alright, now they're bouncing. Or they did bounce a little bit. So, let's see. Self.floating direction times 0.1. That's like a constant. It ends up being constant. I think. Well, it has to be like dependent on the actual velocity, right? The velocity. Self.velocity y times 0.1 times, and we'll probably have to set that initially to, oh, look at the hit floor too, and there's a lot of moving parts, and then there's friction, which I'm wondering does that come into play as well? Self dot I think if I set all the velocities to 1, will that help? I think I can do that down here as well. So that's 0. That's the origin point, I think. That's not necessarily the, like, y. So if I'm having a velocity that's moving upward, let's see. This is advance right here. So the velocity is changing the position of the element to, let's just set it to 1 or -1. Self.velocity.y is equal to self.floating right times 10. Sure, why not? Okay, they're shaking. So if we set the floating limit to 100 and the velocity of y to that, let's take that away. It's probably way too fast. I don't like the balls that they're shaking. I'm trying to make it to where they're like floating and cool. Let's see. But they're just shaking like they have something wrong with them. Alright, well, I'm going to give up on that for now. And I'm just going to give the balls back their random color. That's pretty cool. All right. What happened? Comment this out too. Oh, I see. Aha, this is why I hate Python. Because we had an indentation error and we didn't realize it. Well, it wasn't an error, just indentation logic issue, I guess. So the color, I think back here, that should be setting the color. Defining it as red there. Oh, and then setting it not to self.color. Aha. It's great when you're, yeah. Yeah, it does. It does have that attribute. Sorry. God. List has no attribute red. Color.red. Okay, yeah, not colors. Self.color. Colors. But yeah, it needs to be color. We're only setting one color. There we go, finally. Back to having my colorful balls. Oh my God, there they go. Ah, I wanted to see it. It was beautiful. All right, so I assume that, you know, at some point they'll rise up and... all right, hold on. Having too much fun. Yeah, they're floating, kind of. Oh. Oh my God. All right, watch what happens with these balls and let me know. Again with the audio, man. Again with the audio, and again with you saving me. Thanks a lot, brother. On C++, yes, absolutely. I throw up the fist. I don't know if you could see it, but yeah, dude, C++, it's pretty sweet. It's a shame that they're giving it such a bad name, and then people on the internet are going around also giving it a bad name, mostly out of ignorance, but that's okay. All right, so yeah. Oh, what I mentioned was that I'm gonna go ahead and scale back on this physics engine. And I'm going to go back to GitHub, and I'm just going to copy it the way that it was and replace what were cubes with spheres, because that might have just been the only thing that I had to do from the freaking get-go. It's common to waste time in programming. These things happen. Okay, but this is not it. So GitHub Ursina master. Yeah. Let's go ahead and see. Poke petter. That's weird. Alright, so in here is where I got my example. And we're looking for cheap physics. Cheap. There it is. And I'm just going to copy. And yeah. Now, see what it is giving us by default. Let's see, terminal open. Cheap physics. What has happened? Incorrect sRBG profile asset. Where do we have an asset coming in to play here? That's weird. Cube. Change default. Unknown pipe types. Paste emit keystrokes. What? Well, this looks like... Okay, so I should have deleted this, I guess. I think this is the only thing I need here. I'm not sure where all that other stuff came from. No? Hold on. I'm definitely missing something. Let's try that again. Same issue. PNG warning configure. Okay. That's not how it was before. So why is that commented out? That's weird. But that's not my issue. Why would white cube? I mean, if I just get rid of that. Color.azure? No. Have they updated this? So we have an unindent. Oh, okay. This guy needs to be here. Entity. So entity is not defined, but that should come in from Ursina. So from Ursina, import all. Render is not defined. From Ursina, import all. And then after that, we do the shaders. Interesting. So like from here. It's weird how they have that shader defined in like the middle of it. So copy that. Oh wait. Again, just copy the entire thing. And then the only thing changed was the texture. Incorrect. So it's not the texture. Collider sphere. Texture scale. It's weird. It really was not doing this a second ago. Alright, well I'll have to build my own backup. Not a problem. So here we have a physics entity, and we also have a physics entity here, right? Yeah. So, I mean, when I just scale this guy back to model is plane. What was my model here? Sorry. So down here, also plane. I'm just curious to see here. Sky and run. Ground, sky and run. I copy it over onto cheap physics, which I'm working with. And this is input, but there's throw. I don't need input. Or I do need input. I don't need ball here. I need E to be physics entity, like that. 9-ball triangle, that's not defined. Okay, we're back. But physics entity has no attribute called velocity. Not a problem. Let's see. Here, we're finding a way to... so what we did before was we made it underscore. It's not underscore anymore. It's just dot velocity. Okay, so now we're throwing these cubes. Okay, that's good. The cubes have gravity. They have force until they hit the ground. And now I want to change them to spheres. Give them a sphere collider as well. And I think this might be the only two things I actually needed to do. No. Okay, good. I'm glad I have the justification here because I do require a momentum transfer algorithm. So, in other words, what I'm doing is right. Unless, of course, one of these overridden functions is messing it up. That could be it. Let's see. Let's go ahead and comment out the overridden functions. And let's see what kind of behavior the snowballs have now. Yeah, no, they just stay there. There's no physics in this incorporated at all. That's why we have to make our own physics. Okay, so now we have the justification. Let's go back to this code. And let's try to trim out the stuff that is not necessary. So let's run this. First of all, I know that there's a float function that I did that I just want to completely get rid of because I tried to do that real quick to make it visually interesting. It didn't go well for when I had to go pee-pee. So let's see. Ball, float ball. Yeah, we have another reference to that. I noticed that the fall function is not being applied to all the comparatives, but this should... Let's see. I don't know. I think I need to revise my collision detection function. But anyway, this is where we're at in terms of, what we added onto. And you can see that it does have a momentum transfer. It's just not, something ain't right about it. First of all, if we want to get specific, these balls are not supposed to go into each other. That I tried to change the collider and specify that that it's like bigger. I can try that again, but first, like I mentioned, I want to get rid of all the stuff that I'm not currently using. Like gravity, I'm not using that. Although, I mean, I should. I'll keep it there. It seems to be a vector with a negative z direction. The thing about this, though, isn't that a velocity? Isn't that technically a velocity? Isn't gravity just like a factor, like -9? It's a constant negative 9.8. It's a constant of negative 9.8, I believe, or maybe it's 0.98. Yeah, force of gravity is negative 9.8. So if we're going up at 10 point, it's a force, by the way. So let's see. What do you measure gravity with? Is it its weight? Like you could measure it in kilograms or pounds. Let's see. What is gravity? What is gravity? What is gravity? Physics, 9 meters per second squared. So it's an acceleration. It's defined as a change in velocity. So it's not a force, it's a change in velocity. Yeah, meters per second squared. Okay, and the starting positions, zeros are not quite right. These 0.5s, I think, need to be changed. I think all of these numbers need to be multiplied by 2, at least. 2, 1, 2, 4, 6, 6. I'm just going to set these to 1, 1, 1, and 8, which would be the head ball, I guess. So 0, 0 goes out 3 here, and I don't see a -3, so I assume that maybe this would be actually -3. I don't know. The pattern is not quite making sense. Alright, they're spread further apart, which is kind of good. Yeah. No, I don't like that at all. But I think they do need a diameter of 1. But yeah, that'll work. That will work. All of the Y's are set to 0, so yeah. So one of them is 0, 0, 0. So that one is, I mean, let's look real quick. So this doesn't really matter. I'm just going to look and see if I can see the 0 origin one. First of all, there's only 4 balls there, which means that we're not even completing the loop. Yeah, so the range here is going to be len starting positions instead, so that we can like keep defining them. Yeah, we have a triangle, and then we have this number right here, which is wrong. And if I could guess which one was the 0, I couldn't, unless I specified the color of it. I'm gonna just leave it with the little triangle if I can, and I'm gonna guess that these are the bad values. So let's see what does it look like. Yeah, okay, good guess. Now, to my perspective, when I'm starting out, it's a triangle on its side, which it should not be. First of all, it should be probably not at the 0 origin. I think that with these data types, we can just add 5 to each of them, like that. I'm just gonna test one before I do all of them. I guess you can't. So object of int has no len. Okay, so we cannot do that, unfortunately. So we'll have to do that manually, changing the displacement of these. So it's going to be +5. So 4, 5, 6, 6. Oh my god. 6. And what was it? 4.5 and 4.5. Or wait, 5.5. Wait, sorry. Was that negative or positive? So 4.5 and 5.5. And 5.5. This should translate them a little bit away from me, I think. Wait, did we miss one? Yeah, 5 here. I guess. There's no way that was -5 previously. Yeah. Okay. So now they're kind of far away from me. That's pretty good. I want them to go in the other direction, though, however. So I'm going to just negate all of them. And hopefully that has the effect that I want. Yeah, pretty much. I'm facing this corner for some reason, which is annoying. Like, the relative direction of this... Like, see that? I'm catty-cornered, so I have to, like, look over. It's annoying. Alright. So now we kind of have a triangle. It's not 9. It's not a triangle of 9. I guess we could follow this pattern and continue to get a 9-ball triangle pattern. Let's see. Let's see if Copilot can guess it. that's right. We needed 4 more vertices. And that's, yeah, like I said, that's definitely not right. And it looks like this, what we've done is put it on the edge of the triangle while we're decreasing in the Z. So we need to keep it at the level of, well, we need to go here and we need to make it on this level. So the first one, let's see, we have -5, -5. Yeah, so the most outer one here is probably going to be negative. Let's see, 0.5, 0.5. Oh, it's hard to read this. I think this one is out of place. I think that's what's going on here. So, I mean, I know that this, if I just bring over -6, vec 3, -6. If I bring over -6, 0, and 1, then it should be giving me that, and then like also -5, and then that should be like the back row. Let's see if it is. Yeah, no, not really. So let me comment those out again. And then also, did I mess something up somewhere else? Okay, so that's good. Seems like maybe that was right. And let's include, so we need a 4 there. Maybe we're shifting by, I mean, if I just move this guy down here, I think it belongs. No, it doesn't actually. So this must be, so here we have a scale of 0.5 on this row. Actually, no, we're in the position of 0.5, and then we're surrounding it with, yeah. So no matter what we do, we have a 5 in the back. So I think that it's going to be like these numbers right here. So rather than -6, we do want -6 as our first number. But we also want, let's see, what else? Vec, no, sorry. Vec 3, and it's -5.5. This number should be 1. And then this number, I'm trying to think. Maybe this should actually be 3. I don't know. Let's just see what that looks like real quick. No. Because we have a 2 there. And I don't think the 1 is actually correct somehow. Let's see. So the original triangle is like this one. And these balls are going in behind it. So not quite. We're looking at it wrong. I'm going to move on from the triangle and what's next? Still just removing junk from this, really. So we have a functioning triangle. That's good enough for now. All right, friction type is an enum that we've defined, and that is going to be all the time that I have for now. I'll be back on a little bit later during my lunch hour to get these balls going again, do a little bit of research before I come back. So thank you for joining, and I'll see you next time.